Hello students, welcome back to A-Star Tuition channel. Today, we want to continue our discussion about kinematics, especially about uniform motion and uniformly accelerated motion. Let's start. In our last video, when we talked about kinematics, we learned about motion, one-dimensional motion, that is, in general. However, there are two types of very specific motion that are ubiquitous and is discussed a lot in physics, in high school physics. Now, this motion is called uniform motion, as well as uniformly accelerated motion. Now, what are they? Uniform motion, as the name suggests, is a motion in which the velocity is constant. So there is no acceleration. So this is motion with no acceleration. Uniformly accelerated motion, as the name suggests, the acceleration is uniform, so constant acceleration. So this is a motion with constant acceleration. Now let's discuss this one by one. Uniform motion. So in this case, no acceleration. That means the acceleration is equal to 0. Now what about the velocity? The velocity is constant. So the consequence of the acceleration being 0 is that the velocity is constant. Now we can actually draw the acceleration, the velocity function time graph as this. Now you see that the value of velocity doesn't change. It starts with a certain value, let's say u. U is the initial value. And then as time goes by, the value doesn't change. It remains the same all the time. Now, you probably remember from our last video, if we have velocity function time graph, we can actually calculate the displacement. So you can see here, the initial velocity is u, but then the final velocity, meaning that velocity at any time after that, is the same, u. So then you can calculate the displacement by calculating the area, but this is just a rectangular shape, so you can find the area by multiplying u with t. Yeah, so u times whatever t you, let's say one particular value of t times t. Yeah, so this will give you the displacement. Yeah, displacement is equal to u times t. Displacement is equal to u times t. So this is very simple, and quite frankly, you don't really need to learn kinematics to understand why this is correct. And so this is a bit the same as distance travel. Remember, displacement and distance travel are two different concepts, but then in the case when the velocity remains constant, then the amount of displacement and distance would be the same. Now, in this case, let's say that you have a velocity equal to initial velocity 10 meters per second. So someone is like driving a car with a speed of 10 meters per second, and it's moving to a certain direction. So the velocity is 10 meters per second in that direction. And let's say that the time is equal to 20 seconds. So then in 20 seconds, the displacement would be 10 meters per second multiply with 20 seconds, it will give you 200 meters. So then the displacement is going to be 200 meters from the initial position in the direction of motion, right? So this is quite straightforward, yeah? So there you go. Now what about uniformly accelerated motion? Now, for uniformly accelerated motion, here we define it as motion with constant acceleration. So the acceleration is constant. So we start off with acceleration as a function of time graph. So the acceleration being constant, meaning that as time goes by, the value will remain the same. Like from here, let's say that it has a value of, 3 meters per square second. Now obviously it can be any number, but here let me give you just a numerical value assigned to it so that it becomes more relatable, 3 meters per square second. Now as time goes by, you see that the A again is constant. From the previous video, we learned that if we have acceleration function time graph, then we can actually calculate the change in velocity by calculating the area under the acceleration function time graph. So we say that the change in velocity in this case is the area, and the area is simply whatever the value of A is, multiplied by the elapsed time. Elapsed time, so how long the time has gone by since the initial time. So this is A times T, because it's a rectangular, so rectangular again. Let me, so whatever the value of A here is, multiplied by the time, it's going to give you the change in velocity. Now change in velocity is final minus initial. So change in velocity is equal to final minus initial. So phi minus u. So phi here is the final velocity, and u here is the initial velocity. Now if we move u to the other side of the equation, we'll wind up with one of the equation that you will see pop up everywhere, the so-called the SUFAT formula, and this is one of them. So that in the case of uniformly accelerated motion, you can find the change in velocity by multiplying the acceleration times time, because the acceleration is constant. Now the way to make sense of it is, imagine that you have an acceleration of 3 meters per square second. Now, as I mentioned previously in the previous video, this can be understood as 3 meters per second, which means that the acceleration will increase. The velocity will increase by 3 meters per second for every second of time. So you imagine that if it starts from the velocity equal to 0 at less, then after 1 second, the velocity will become 3 meters per second, because it increased by 3 meters per second in every 1 second. Then at t equal to 2, the velocity will increase to another 3, so 6 meters per second. And t equal to 3, the velocity will increase to 9 meters. So then you can continue the process. In general, we can deduce that the velocity will become at, and obviously you add u in it. Now in this case the u is 0, but the u doesn't need to start from 0. So this why it makes sense, why the formula u plus at makes sense. I hope you understand this. What about displacement in uniformly accelerated motion? How do you find it? Now again, remember, in order to find displacement, we can do that by using velocity function time graph and then calculate the area. Now remember, here you can see that phi equal to u plus at. This is actually a linear function of time, where you can see that the velocity is a linear function of time. So u is a constant, a is a constant, t is the only variable. So I can actually draw the graph of x, or this, not x, sorry, velocity function time as this. So it's a straight line because linear. Now remember that linear, constant, in this case a here is the slope. It makes sense. Remember that the acceleration is the slope of tangent line of velocity function time. But in this case, because it's a straight line, then you can just find the slope of the tangent of the straight line to find the acceleration. So then here this is u, and the acceleration is equal to the slope. Yeah. So in other words, you can find, let's say this is phi, so this is u. So then if you do phi minus u over time here, that gives you the acceleration. So a is phi minus u over time. Yeah. Okay. Now how do we calculate the area under the graph? Now you can see that they are actually a triangle. Yeah, you can see there's a triangle over here. This is triangle. Oops. The triangle is this, and beneath the triangle there is a rectangle. Yeah. So we need to find the area of this one by one. You can actually use the trapezoidal formula if you're familiar, but then you know, most students will break it down into two areas. The area of the rectangle is u times t, yeah, and the area of the triangle here is, now you can see this is phi minus u, and then this is t, so this is half times phi minus u times t, and so half times base, which is t, times height, phi minus u. So then you consider the total area would be u times t plus half phi minus u times t. Now remember that here you know, phi minus u is equal to at, so you can replace this phi minus u with at, so x becomes ut plus half at squared. So this is the formula for displacement for a uniformly accelerated motion. Yeah, so this is the velocity function time, this is displacement function time. Now these two actually these two formula is quite you know, it's quite famous actually. You can actually, if you Google SU phi at, you will find this formula, yes, SUFAT. But the thing is that in addition to these two formula, there's actually additional derivative. Derivative means that you can derive the other two formula from these two. Now what are they? Okay. Now here you can see that x equal to ut plus half at squared. Remember, u is the initial velocity, yeah, and phi equal to u plus at. Now what we can do from here is, what if we want to find a relation without the time? So here you see there's a time. This is quadratic function of time, and this is linear function of time. What if I replace the time from here and then substitute here? What happened? Okay, so again here, if I can actually write the time as t equal to phi minus u over a. Yeah, phi minus u divided by a, and then I can use this value of t and substitute here. So then let's see what happened if we do that. So x would be u times phi minus u over a plus half a phi minus u over a square. So x becomes uv minus u square over a plus a times phi square minus 2uv plus u square divided by 2a square. Yeah, now you can see that I can actually cancel one of the a here, and then you have 2a for the second fraction, and 2a is the denominator of the second fraction, and a is the denominator of the first fraction. Now you can actually equalize denominator. You can do that by multiplying this with 2, the denominator by 2, and the numerator by 2 as well. Yeah, and then you can combine, and you'll wind up with 2u phi minus 2u square plus phi square minus 2u phi plus u square, and then the whole thing divided by 2a. Now, there's cancellation. You can see that the 2u square, the 2u and this minus 2u, they cancel. And then you left with what? X equal to, this is minus 2u square plus u square gives you minus u square. So you have phi square minus u square over 2a. And then if you cross multiply, 2ax equal to phi square minus u square, and phi square equal to u square plus 2ax. Now, so this is another formula that is also part of the SUFAT formula that we use for uniformly accelerated motion. So we usually use this formula if we want to find the relationship between initial velocity, final velocity, displacement, and acceleration without time. So then you can see 1, 2, 3. Now there's another formula, actually, the last one, the last one in the SUFAT series, which is this. How do you calculate the displacement? Now displacement is equal to ut plus half phi minus ut. So what happens if I don't replace phi minus u with a? Remember, earlier I replaced phi minus u with at. If I don't do that, what happens? Now, if I don't do that, you can see here, if I simplify, x equal to ut plus half phi t minus half ut. So the ut minus half ut equal to plus half ut. So it becomes half phi plus u times t. So it's just simply the average of the final velocity and initial velocity, and then multiply with time. So it gives you this. So now you can see this formula that is widely used in uniformly accelerated motion. So this bit, so let me just half of phi plus u times t equal to x, okay, and then x equal to ut plus half at square, and phi equal to u plus at, and phi square equal to u square plus 2x. Now, in general, you do not have to memorize this formula, because when you take something like AP or IB or A level, those formulas are usually provided for the students. So all you need to do is how to understand where they are applicable in the problem. So this is the summary of the uniformly accelerated formula, the so-called SUVAT formula that you will be using a lot in problem solving. Okay. So again, uniformly accelerated motion with constant acceleration. Now, there is actually another type of motion, but actually it's still considered uniformly accelerated motion, which is what we call as vertical motion. So vertical motion is actually subject to gravity. So when you let's say you have an apple in your hand, and then you drop it, what happens is that you can see that the apple is increasingly, the speed will increase. It will speed up, and eventually it will reach big enough or large enough velocity that if it hits the floor, you might hear a sound of the collision, right? Now, that kind of motion is called vertical motion because there is a uniform acceleration in form of gravity. Okay, so we call this, the acceleration is called the gravitational acceleration. Now later when we talk about gravitational law, we will actually discuss further. But then for now, suffice it to say that by everyday experience, you see that when an object drops from a certain vertical position, the speed will increase, and the increase of the speed is due to gravitational acceleration. Now, so then we can still use the SUVAT formula, only usually we change it a bit, we modify a bit. We modify A to be minus G, so which is the value of the gravitational acceleration. By the way, the value of gravitational acceleration G is not necessarily constant throughout the surface of the Earth, but then generally speaking, we can use 9.81 as an average value, meter per square second. Or if you are doing multiple choice question in which the calculator is not allowed, then usually for practical calculational reason, you can just use 10 as well. Yeah. So either 9.81 or 10, depending on the circumstances in which you encounter the calculation. Okay? So because of that, now the reason why I use a minus, because of the thing is that here you can have a situation where you start, let's say you have an apple and then you throw it upward. So it has an initial velocity that is positive, but then the acceleration is actually negative, which is, it's always downward, like the way, yeah. So that in this case we can write the v equal to u minus gt. So then you can see I just replace a with minus g, and the x equal to ut minus half gt squared. Now usually I only need to use these two equations. Yeah, these two is also applicable, but we don't really need that. Yeah? But for the vertical motion, we only need these two. Last, let's talk about the notion of speeding up and slowing down. Okay, so you probably heard the term acceleration and deceleration. So what does it mean to accelerate and what does it mean to decelerate? Now, deceleration means slowing down, but it doesn't always mean that the acceleration is negative. In fact, in order to determine whether an object is speeding up or to accelerate, or when the object is slowing down or to decelerate, there are actually two things that we need to have in our mind, which is that when we talk about speeding up, this happens when both velocity and acceleration are in the same direction. Now, for instance, if in one-dimensional motion, when a particle is moving or when an object is moving, let's say to the right, now you can see that the velocity is to the right and the acceleration is also to the right. Let's put a number, velocity 2 meters per second, and then the acceleration also to the right, let's say 1 meter per second. So then you can see 1 meter per square second. You can see that the velocity will increase by 1 meter per second for every second. Yeah. And another example is obviously if the particle is moving to the left, let's say this velocity is minus 2 meters per second, and yet the acceleration is also to the left. So meaning that the velocity will decrease by 1 meter per second every second. However, decrease means it's becoming more negative. So you can see that it's speeding up, but to the negative direction. Now, on the other hand, when we talk about slowing down, this happens when both velocity and acceleration are in opposite direction. Opposite direction. Meaning that the velocity is going one way, yet the acceleration is going the other. So, like the example would be Now the particle or the object is moving with the velocity of 5 meters per second to the right, but yet the acceleration is minus 1 meter per squared second, meaning that every 1 second the velocity will decrease by 1 meter per second, and hence you can see that the velocity will become less and less positive, so it slows down. And obviously the other example would be when the velocity is, let's say, minus 5 meters per second, so it's moving by 5 meters per second to the left, yet the acceleration is opposite of that, let's say 1. So meaning that the velocity will increase by 1 meter per second for every second, so you can see that the velocity will become less and less negative, so it slows down. So I hope this video give you lots of understanding about more understanding about kinematics, the concept of uniform motion, uniformly accelerated motion, as well as the concept of speeding up and slowing down. So I'll see you again in the next video for part 3, but don't forget to comment, like and subscribe to the channel. I'll see you again.